we have got two machines and n jobs. Here, the number of jobs are 5. Job 1 to job 5. So in the n job, n equals to 5, right? So we talked about how do we sequence using Johnson's algorithm or Johnson's procedure. So we have formulated, the methodology to find out the sequence. Then without this sequence, we'll be finding out the optimal time and elapsed time as well as the ideal time of the machines, both the machine A and machine B, right? So in this lecture, it's an extension of that, right? So in the previous case, we talked about 5 jobs, but in example 2, we'll be looking into 6 jobs. Initially, we'll be looking into order A, B. Then also we'll look into the other way around, like the order B, A. Then we'll see how the implications of n jobs and 2 machines using Johnson's procedure, right? Right. So this is a typically n job and 2 machines. We have got n equals to 6, which is 6 jobs and 2 machines. Let's look at that. Like it'll be a recall for your previous example. So here it is. Like the first thing, we'll be looking into machine A, machine B. Then this entire matrix, and out of that, we'll look into the minimum duration. Say these are the durations or the operation time for machines for the corresponding jobs. Say job 1 has got 2 minutes duration for machine A, whereas it has got 6 minutes for machine B. Say the overall minimum is 2, so that's why we picked 2, and we allocate to machine A the job 1. So that's why machine A job 1, right? So we will be listing down these 6 jobs, and left side will be machine A, right side will be machine B. The reason is that the order is AB. If it is the other way around, it should be machine B and machine A. So we'll take a look at that also. But as of now, understand that we have got machine A and machine B, and 6 job, and the first allocation goes to machine A since 2, which is the least among the overall, and then that corresponds to job 1, machine A. So that's why we have got job 1, machine A, right? Next, once we do that, we'll discuss this complete set, complete job, right? So we have taken out job 1, so that's why we masked here with the black, right? So next will be the minimum among these things, right? So kindly take a look at here is that, like if you pay attention to this, there are 2 threes, like 3 for job 4 and 3 for job 5, right? So generally we will be taking arbitrarily. Say we can take 3 for job 4 and allocate to machine B, or you can even take job 5 and you can allocate to machine, that's also B, right? So instead of 4, you can also allocate to machine 5. But there's something the experts say that you have to choose when there is a tie between two. If it is a tie between B and A, then you can select the order, whichever order comes first. Say, for example, if instead of 7, it says a 3, that's for machine A, whereas another 3 is for machine B, right? So in that case, we'll be selecting machine A because of the order. Like we will choose that as an order for initially we'll pick that particular machine. So in this case, luckily we don't have tie between machines, but it is tie among the same machine. Like so among the same machine between the jobs J4 and J5. So people prefer to take a job which comes in the earlier. Like for example, if you take look at job 4 and job 5, job 4 comes first than job 5. So that's why we do choose this particular job 4. But many argue that it's just like a matter of discussion. But people can take it arbitrarily. So you can even take it arbitrarily, and you can even still get the same solution, right? So you can give it a try. So I've considered J4, and you can take a look at the J5, and you can do this problem and let me know whether you get the same solution or not, right? Right. So job 4 goes here, and then once we do that, we'll mask this job 4, which is job 4. The minimum is machine B, so that's why we allocate here. Then once you remove that, this one of the 3 gets eliminated, so the other 3 will be the minimum. So the job 5 will be minimum. That is also machine B. Then we can allocate here, right? But if you choose arbitrarily this 3 initially, job 5, then it will be like J4 and J5. So that's the only difference. But otherwise, if you choose it by the way, the convention as I told you, then you will get job 5, then job 4, or in this case, job 4 and job 5, something like mission B is from this side, right? Right. So once you do that, you will be masking it J5 also. The remaining will be J2, J3, and J6, right? So among this, 4, 9, 7, 4, 4, 11. So if you could see here, if you could see here, there are so many minimums. The reason I select this particular problem is that there are a lot of ties here. Like here, there's a tie we removed arbitrarily by choosing this, and here is a tie uh, we have to remove somehow, right? So how do we go about and do that is, you can see, you can take a look at it here. There's a 4, which is job 2 of machine A, and there's another 4, which is job 3 of machine B, and there's another 4, which is job 6 of machine A, right? So as I told you, if there is a tie between machines like machine A and machine B, then you have to choose the order, like which order that it follows. It's order A and B, right? So in that case, we'll be looking into this 4 and this 4, not this 4, because this is corresponding to machine B. So that's why I just go and remove this particular thing from the consideration. Now it is job 2 versus job 6, right? So as I told you, both are A, and this procedure follows, right? So uh, job 2 comes before job 6. So which means that it will be wise if you choose job 2 rather than job 6. I repeat, initially we have got 4 in job 2 for machine A, job 3 for machine B, and job 6 for machine A. And we eliminate or discard this particular minimum because it is in machine B, which comes the later. Like it is A to B, not B to A. If it is B to A, we have to consider a little bit different, right? So otherwise, it is probably the same, right? Then among the machines, you have to choose a minimum that comes in the initial or the in the initial stages of the jobs. Like for example, among the existing job J2, J3, and J6, J2 comes first, so we will allocate that to machine A. We will discard this particular 4. So that's what basically it means, right? That's why we have allocated J2 here rather than J3 for machine B or J6 for machine A, right? So that's why once we do that, we can eliminate this particular job 2. Then we'll be left out with only J3, J3 machine B, and J6. Here's also a tie. Here is also a tie, so we can have a look at stuff. But the order, you can maintain the order. Instead of, I think instead of J6 we can take instead of J3 we can take J6, and finally we'll be ending up with J3, right? So that's on pending. Say I'll be copying this particular cell here, and J6 gets masked, right? So that's the logic. Then once it is done, we will be taking J3, right, somewhere, right? So this is how you generally perform job 1, job 2, job 6, job 3, job 5, job 4. So this is the sequence based on the Johnson's algorithm. Let's take a look at. All right, so this is the sequence. We got it for order A to B, right? Right, so this is for the order. So we'll be doing job 1, job 2, job 6 or something like that. Let's come back to this little later, right? Say this is how we, right? So what happens if we reverse the order, right? Say instead of machine A, B, the order is B, A now. So let's take a look at that because that is very, very important that you should really know. Let's discard this for a moment. All right, so we'll come back to that little later. Let's take a look at how the order, when the order gets changed or the order get reversed. Since we have got only two machines, so it's almost a reversal of the existing order, right? Right. For example, here job 1 to 6 is fixed, but machine A and B were given, but it has to be reversed. So the order is now B and A. So you put an extra column called order DNA and you change the or reverse the particular rows. Like the first will be machine B, then followed by is machine A, right? So this is machine B and this is machine A, right? So this is typically, if you could see, it's a reversal of the previous thing, but sometimes it will be misleading. Here it is, actually it is machine A here and machine B. Sometimes you can even give machine B to machine A, right? Say when there's a reversal of an order, we'll be considering that particular machine B and machine A, right? So I'll just discard this for a moment. And let's take a look at it. Let's take a look at that. All right, so the reversal of the order. All right, so initially we'll be looking into the overall minimum. So the overall minimum falls here, which is job 1 of machine A. So that's what we can put it here. We can have job 1 of machine A. So then we will be discarding this. Then we'll be looking into the minimum of the other things. Like in this case, we have got 3 and 3. Say we have got tie between the minimum, so 3 and 3. But luckily, both are in the same machine. Say we will be selecting whichever is earlier. So in this case, the earlier is J4. So that's why we have got J4 here. And then once we do, we will be masking that. Then the next step will be finding out the minimum. In this case, it will be J5. Machine B suggest. Oh, this is all machine. This is machine A. It has to be machine B. Machine B. It is J4 and J5. Right, something like that. So machine B is green. Take a look at that, right? So this is pretty much the thing. So once we do that, we'll discard J5 also. Let's take a look at that. Okay. So I'll just repeat. So initially it's J1 for machine A, which has the least. So once we do that, we will be masking that particular, thing, right? So next will be minimum among this. That's a minimum among 3 and minimum among another three, which is J4 and J5, then we will be selecting, J4. So J4 belongs to machine B, right? Say, I'll just say, right. Next, once we do that, we'll be discarding this particular thing. And also already discarded J1, right? So next will be minimum here. So that will be J5. So that's what is given here is J5, right? Then remaining stuff like J2, J3, J6. There's also a tie. Like if you take a look at that, there's a tie among different things. Like in this case, it is J3 for B. Then machine A, it's 2, and machine A is J6. So if you take a look at that, this is an order of B to A. So which means that we will be considering this small entity here, right? Say small entity here, right? So we'll be discarding this 4, which is the later one, which is machine A, and then we choose J3, using J3, which is machine. I think it's machine B. Yeah, this is machine B. Then once we do that, we will be masking that. Right. So next we left with only J2 and J6. Then obviously it's both falls on machine A. So we will be keeping that the one which comes early. So it will be J2, and then finally it will be J6. J2, and that gets masked here. And it gets masked, and finally we'll end up with J6, which is machine B. J6, which is right on it. All right, so we have arrived a sequence. If you compare both, let me copy this. And yeah, so when you do the reversal of the order, we have got J4, J5, J3, J6, J2, J1. Copy this and put it in the sequence. So that's why the Johnson's algorithm was so effective that it will be useful for finding out the ideal time of machine B and 8 facts on it. And same way, if you take a look at that, and I'll just paste it here. So that's for A to B. Right? I'll just also do a comparison side by side. For A to B, this is the procedure. This is the sequence, optimal sequence. Johnson's based on Johnson's procedure. And for B to A, this is how it is, something like that. But if you take a look at that, you'll have both 3 allocations for machine A and 3 allocations for machine B. And same B here also 3 allocations for machine A, 3 allocations, B and A. Right, so, but the order gets changed. You see J1, J2, J6, and it is J1, J2, J6, and J3, J5, J4, and J3, J5, J4. It is almost the reversal of A to B is B to A, right? So it sometimes it may be other way around also, depending upon the allocations, right? So in this case, luckily we've got both things to be reversal, right? All right, so let's move on to the stuff, the order A to B, right? Say zoom a bit so you can understand much better. Right. So here we have got machine A to B. This is order AB. Order AB. It's very important to know the order, right? Um, so first what we do is we'll be listing down the question or the given problem. Then this is order AB. So we'll put machine A first and machine B second. Then time in, time out for machine A and time in, time out for machine B, and then idle times and so on, right? So this is all right. So this will be the general procedure. So this difference will be the idle time, and this difference will be the idle time. This is the elapsed time, right? Let's save this. Right. So the first thing is job one for machine A. So the job one for machine A starts at 0, then 0 plus the duration of J1 for machine A. So that is 2. So that will be 2. And time 1 have to wait till this machine A gets over, which is this timeout of machine A. Right. So that will be 2. Then time out of machine B is, which is the job 1. So job 1 completes by 2 plus 6. Job 1 for machine B is 6 minutes. So it will be 2 plus 6 is an 8, right? So that's pretty handy. Then time in for job 2 will be the time out of job 1. So this, then this plus machine A job 2, machine A job 2 is 4. I click here, it's 6, right? So here it is this one, because 8 is greater than 6. So machine B can very well start after 6 minutes. If it is have anything less than 6 minutes, then we need to take this particular time here until machine A gets complete. Machine B cannot start. So since luckily we have got 8 here, which is this already a huge time after 6, so we can directly put it here. Then this plus job 2 of machine B. So job 2 of machine B is 7. I can take a look at that. Here it is, it's 15. Then this will be the in time of 6 equals to the out time of J2. So that will be 6. And what is job 6 of machine A? It is 4. So it will be 6 plus 4, which is 10. Whereas it's very well ahead. So that will be 15 here, which is this. Right. So this will be 15 plus job 6 of machine B. So that will be 11. I shall take that. Look at that. 11. So the in time of job 3 is the out time of job 6. So that will be 10. And what is job 3 of machine A is 10 plus job 3 of machine A, that is 9. Take a look at that. It is pretty well ahead, so we can put 26 directly. And if you take a look at that, it is 26 plus job 3 of machine B. Job 3 of machine B is just 4. This will be 30. And this will become 19. And this will become 19 plus job 5 of machine A. It's 7. It's 26. Can very well put 30 here, which is this value. And this value plus job 5 machine B, which is 3, become 33. And you can extrapolate this stuff here, 26. Then this will be 26 plus job 4 machine A is 6, which is 32. And we can pretty well put 33 here, and 33 plus job 4 of machine B, which is 3, which is 36. And no ideal time for machine A because it starts first, but this is a lead time, which means that machine A finishes the activity by 4 minutes because the elapsed time is 36 and it gets completed by 32. So we have got the 4 ideal time, 4 minutes of idle time, right? So this is how we calculate the idle time of A. And then idle time of B is that this gets delayed by 2 minutes. So that's a 2. And if you take a look at that here, like 15 15 is greater than 10, then 26 is greater than 19, then 30 is greater than 26, then 33 is greater than 32. So there's no idle time for B. So B will start immediately. Say it gets over by 10 minutes, it starts in 15. It gets over by 19, it starts 26. It gets over by 26, it starts at 30. It gets over by 32, it can start 33. The problem comes when there is a dependency. This is lesser than this one, right? So this is lesser than, this is lesser than this one. Then only we have to make this particular cell to be here. So this value, say in this case is 30. Say for example, if this case is 30 and if this is 32, you cannot start 30 because already the end time of machine A itself is 32. So we need to start only at 32. We have to wait till this machine gets over. The operation in the machine gets over. So that's how. But luckily in this case, there isn't any ideal time whatsoever. Right. So this is the order AB. Let's take a look at the other thing, which is the order BA. Order BA. Say we have to put B and A, or you can even take A and B. There's a question, but you can make up from the sequence from this, right? But it'll be better if you put B and A. You just interchange the rows. That'll be easy for you to do it, right? This is also pretty similar. Say this is machine B, this is machine A, right? So job 4 of machine B. Say job 4 of machine B is 3. Say the initial duration is 0, and it will be 0 plus job 4 of machine B, that is 3, right? Then it has to wait 3 minutes. The machine A have to wait 3 minutes. That's why the idle time is 3 minutes. And job 4 of machine A. Job 4 of machine A is 6. So that will be out time. So 3 plus 6 is 9. Right. So this 3. It has to wait till the 3 minutes gets over. It starts at 3. Then its own duration is 6 minutes. So 3 plus 6 is 9. Right. Then we will be putting this particular stuff here. This same 3. Then what we generally do is job 5 of machine B. Job 5 of machine B is 7. 3. Beg your pardon. It's 3. So it's 3 plus is 6. So we can directly put 9 here because 9 is greater than 6. And job 5 of machine A. Job 5 of machine A is 7. It's 16. And this will be an we'll come back to this little later. All right. Then what else is it'll be 6. Then job 3 of machine B is 4. So there will be 6 plus 4 is 10, and you can very well put 16 here, which is ahead of that time. Then 16 plus job 3 of machine A is 9, so it will be 25. And here we will put 10. This value equals to what is job 6 of machine B? Is 11. Say this is 21. And we can pretty well put 25 here because 25 is greater than 21. Then 25 plus job 6 of machine A. Job 6 of machine A is here. It's 29. Then I'll just put 21 here. Equals to J2, which is 21 plus 7. This is 28. It can pretty well start at 29. Absolutely. Then this will be 29 plus J2 of machine A is 4. It's 33. And you directly put 28 here. And it will be 28 plus job 1 machine B is 6. It's 34. And you cannot put 33 here. So here is the big part, because here it is 33. You cannot put 33 because the machine itself is available at that point. Like you cannot go go beyond its purview. So that's why we directly substitute 34 here, which is greater than 33. And then finally, it will be 33 plus J1's duration of machine is 2. And we have got ideal time of machine age is only for 2 minutes, right? So in this case, it's probably the same. I think here also is the same. So no idle time for machine B. It initially waits for 3, and then if you take a look at here, so this is how you do. So 34 minus 33, so that will become 1. So that will become 1 minute extra the waiting time for machine B. So machine B, the operation of J2 gets completed by 33 minutes, but it has to wait till 34 minutes since the job 1 out time is just 34. So that's the difference is what we call the idle time of machine B. So machine B has to wait till then. So a total of 3 plus 1 is 4. And an idle time of A is just 2, which is the elapsed time minus the final output time. So this is also known as lead time. It's not lag time, it's a lead time. It finishes early, but these are the lag time or the idle time. So they are behind the machine A. In this case is machine. So I think we have to reverse the order also. This is B and this is A. Right. So this is how you generally find out the ideal time of machines if the order is A to B. If the order is A to B, it is 4 plus 2. The order of B to A, it is 2 plus 4. It's 6 duration. So, and the sequence gets varied, right? So it's almost a reversal of the sequence, right? All right. So that completes, example 2, which is very simple, which is very different from the previous one, where in which we didn't have any tie. All the values are distinct value. Whereas in this example, we talked about ties between the machines and also between the jobs of the same machines. So this is a typical example of how you rectify that. Right. So that's a very important thing. Next, we'll take a look at a very, very important problem, which is called n jobs in 3 machines. And so far, we've been doing n jobs in 2 machines, be it 5 jobs or 6 jobs or any number of jobs for 2 machines. But how are we gonna do for n jobs and 3 machines? Right. So this is a really, really important problem. And the order I just take is not ABC, it is ACB. So remember, this is one of the common mistakes students will make whenever a problem on sequencing is asked. They don't generally look into the order which is mentioned in the question. They straight away try to solve it in the same order given, right? So kindly spend extra time on looking into the orders, like the orders provided. If there isn't any order provided in the question, which means you can very well choose the order you like or the default order of ABC and so on, right? Something like that. Right. So this is typically a 6 job and 3 machines problem. And in fact, Johnson's algorithm or Johnson's procedure, you cannot solve more than 2 machines. Right. So the maximum solvability for Johnson's procedure is 2 machines. But when we have a more number of machines, you can very well convert that into an equivalent number of machines. Say in this particular example, we'll be converting the 3 machines into 2 machines or 2 equivalent machines with some basic procedure. So let's take a look at what are the basic procedures. Right. Say once a problem is given and check the order and you arrange the orders based on that. Like you arrange the given problem based on that. So in this case is machine ACB. So that's why machine A from here the row remains the same. Whereas machine B and machine C gets machine B and C gets reversed. Say B row and C row the reversed. So that's why it is C and B. And to avoid confusion, you can name that as row 1, row 2, and row 3 as well. Like in case of a simplex method, we talked about row 1, row 2, row 3 for performing elementary row operation. Remember that this will be useful for arithmetic operation in the later on stages. Right. So first is solvability. or I can even call check, or something like that, right? So solvability. Uh, can we convert this three machines into two machines or two equivalent machines problem by using these two conditions, right? So it's not very difficult condition. It says that minimum time on row 1 should be greater than or equals to maximum time on row 2. I repeat, minimum time on row 1 should be greater than or equal to maximum time on row 2, right? So the minimum time of row 1, among this the minimum time should be greater than or equals to maximum time of row 2, right? So another condition is that this is OR condition. You can have condition 1 or 2, but any one should be satisfied. So that's the basic logic. It is not like both should be satisfied. It is any one should be satisfied. If none of these is satisfied, then you cannot convert the three machines into two machines problem. So you have to terminate at that point itself, right? So the next thing is minimum time on row 3, which is equals to greater than or equals to maximum time of row 2, right? So which is pretty much simple, like row 1 has minimum value, so R1 minimum should be greater than equals to R2, I mean R2 maximum, right? So greater than equals to maximum of row 2, and this is pretty true. I'll just put it here. It is pretty true for row 3 also. So minimum of row 3, which is equals to greater than equals to maximum of row 2. Right? That's what basically. If any one of these condition gets satisfied, then we can pretty well solve this problem or convert the three machines into two machines or two equivalent machines. That's it. Right. So condition 1, minimum of row 1. So the minimum of row 1 is 2, right? So minimum of row 1 is 2, and the maximum of row 2. So a maximum of row 2 is 8. So it is 8. So which means that 2 is not greater than equals to 8. So the condition is false. Right. Let's take a look at the second condition. Right. So minimum of row 3. So the minimum of row 3 among 13, 14, 9, 12, 8 and 13. The minimum is 8, and that is here. And maximum of row 2. So we have already found out what is maximum of row 2. Among this 8, 6, 4, 6, 3, 1, 8 is the maximum. Say in this case 8 is greater than equals to 8, or it is 8 equals to 8, then this condition is true. So which means that, so we have found out a condition that is promising to convert the three given machines into two equivalent machines, right? Say, how do we convert this equivalent machines? That M will now convert the three machines into two equivalent machines, like machine 1 and machine 2, right? So how do we go about and do that is, we'll add both the rows, like 3 plus 8, and that will have it as a machine like M1 equals to row 1 plus row 2, like this is row 1 and this is row 2, right? And M2 row machine 2 equivalent machines, right? So that will become row 2 plus row 3. So this is for two machines problem. We'll be discussing about multi machines problem later on. For a for a three machines problem, in order to convert into equivalent machines like M1 and M2, we'll add this particular row elements with this particular row elements and form a new machine. And we'll add this particular row elements and this particular row elements together element wise, and that will become M2 or equivalent machine 2. So that's what it is given here. So this is A plus C. Since the order is A, C, B, so we will be taking A plus C plus C plus B. If it is A, B, C, we will be taking A, B plus B, C. So that's how the order is. So that's how it is. Like I can even do a demonstration of it. Like this is A and C. Say I will put A and C. Will be job 1, job 2, think it is job 6, right? Say, when I drag it, I will get exactly the addition of A and C, right? Say, the next case will be C and B plus become for job 6. So that's why we have got this here 11, 21, 18, and 20. So which means that we have converted into two equivalent machine. And from this point onwards, it will be pretty fairly the same. The procedure which we have discussed early, it's fairly the same, right? Say we'll be putting machine 1 and machine 2. And among this, we need to find which is the least. Say in this case, 8, which is J4. So you substitute J4 here. Then followed by, then we'll mask that particular column. Then out of remaining, the minimum is also in machine 1, which is J3. So we put it in J3. Then we mask that J3 column. Then remaining is 11, 18, 12, 12. And there's a 11 also. There's a tie actually. So here is 11, here is 11. And as I told you, when you have type between machines, you take a machine that comes early in the order. So in this case, it's an order of M1, M2. Obviously, because it is AC and CB. So it is very well taken. So that's why we take J1 here instead of this. So we will be discarding this. We're discarding that for machine 2. So we'll take J1. And we'll mask that, and then next step will be J5, which is machine 2. So we'll substitute J5 here, and then we'll mask that, and finally we'll have end up with J2 and J6. Among this, the minimum is 12, which is for machine 1 job 6. So that's why we'll put job 6 here. Then we'll mask that, and we don't have any other choice, only with J2 and J2 machine 1. So that will be here. And finally, you will be substituting here in this particular sequence. And based on the machines A, C, B, we'll be finding out. So far, we have done only 2 machines. Here it is the third machine because it's a 3 machines problem. But the sequence for only for finding out the sequence, we have taken the equivalent machine 1, machine 2. Whereas for solving the problem, we need to take the entire stuff like machine A, machine C, and machine B. Right. So machine A and machine B is fairly the same. Machine C, the third machine is that we have to wait till this machine C gets complete. So that's why here we have 8. Otherwise, it's fairly the same. Right. Say maybe we'll take a look at that. Maybe we have got time to discuss that. All right. So I think it's file time machine. All right. So let's clear this off. All right, so let's take a look at that. So it'll be easy for you to understand. Right. So the order is machine A, machine C, then machine B. Right. Say somewhere down. Right. So the job sequence are J4, J3, J1, J6, J2, and J5. Yeah, it's correct. Then what we have to do is first is machine A, and I've arranged it. You can even do one thing. You can even arrange it like A, C, B. Get this row and all right. So you can put it as per the order ACB, right? Say job 4, it starts at 0 duration, and it's a first mission. And job 4 of mission A is 2. It is 2. And the time in for mission C is 2 because it has to wait till then. Then the time out for mission C for job 4 is 2 plus. What is job 4 mission C? Mission C is 6. Look at that, it's 8. And the machine B has to wait till this gets over. So it is 8. So that is why the ideal time for machine C is 2, whereas the ideal time for machine B is 8 minutes. So 8 minutes from the beginning, from the A till this to get into B, it's 8 minutes. So it's not like from C to, but obviously C will be performing till 8. So you have to wait till. So it's an overall wastage of time or waiting time or idle time. Then job 4 of machine B is 12. So this is very much heavy. It's 20. Then you can directly put here. Then job 3 of machine A. So job 3 of machine A is 5. And you can pretty well substitute 8 here because this is greater than 7. Then job 3 of machine C. Job 3 of machine C is 4. You can pretty well put it 12. So you can even put it to 20, which is greater than 12. Then you can take a look at 20 plus machine B J3 is 9. So it's fine. And then the 7 comes here. Then it will be 7 plus job 1 machine A. Job 1 machine A is 3. It's 10. It's fine. We can put 12 here because 12 is greater than 10. Then 12 plus job 1 of machine C is 8. It is 20. And it is fine because it's 29 here. Then 29 plus, job J1 of machine B, which is 13, which is 42. Fairly good. 1. And plus J6, job 1 is 11. And it's 21. You can see that you cannot start this as 20 because its elapsed time or the finishing time of that itself is 21. So we'll put it this one and this one plus C J6, just 1, 42. And it can very well start at 42 because it gets over by. And in here we have got idle time as 1. The reason is that we can take a look at this and this. The difference of 21 minus 20 is 1. It's correctly reported here. And this is job 6 of machine B. Job 6 of machine B is 30. So it's 55. And then here we'll put the in time. And job 2 of machine 1 is machine A is 12. So 12 is 33. And you cannot start 22. The reason is that 22 is less than 33, so we directly put here 33, and that will be 33 minus 21 is 11, so it is correctly reported. And finally it is 33 plus C of machine C job 2 6 is 39, and we can very well put 55 here. And then 55 plus machine B J2. Machine B J2 is machine J2 is 14. Right? So that's 69. And this will be this. And this will be this plus J5 9, which is 42, but you cannot directly put 39 because that's very heavy. 42 plus J5 of machine C is 45. Then you can directly put 69 here, which is 69 plus J5. Okay, it is 77. And that's how it is. So this difference, ideal time of machine B to machine C is here. I think it is ACV, correct? Yeah, 32. And this with machine A is 35. So 77 minus 42 and something like that. And there is no idle time for this thing itself. 77 minus 77 is 0 because that's elapsed time. And you can see in the initial stage, we have got 2 and 8, which is that. Then finally, from this point, we have got 11 and 1. So it's 11, 1, and 3. and that will be 49. So it's a lead time of it. And this is the total ideal time. So this is the uh, lag time and this is the lead time. So you can differentiate that. This total is 49. So the lag time is the sum of how lagging or ideal is this one. And the lead time is this time. So after that, what's the time it is waiting? So it's a lag or ideal and it's lead. All right. So that's basically the stuff. I think it's the this is the lead time, something like that. And this is the total wastage, which is the sum of the above two things. Which is this addition something. Okay. So this is or you can even have a grand total also, total wastage of time. So 92 minutes gets wasted in transition. It's an optimum wastage. If you try to solve this by regular method, then you can probably get more wastages or something. All right, so this completes today's lecture.